You ever stare at a math problem and just feel stuck? That little bit of panic starts to creep in, and you get this feeling that your brain just isn't wired for this stuff? Well, if that sounds familiar, you are so not alone. For a lot of us, math feels like this exclusive club that we never got an invitation to.
It's a super common idea, right? The math gene. The French even have a cool name for it, the bas des maths, which means the math bump on your head. The idea is you either have it or you don't. And that idea is so powerful, it can create a mental block before you even pick up a pencil.
Today, we're going to flip that idea on its head. We're actually going on an investigation, and it's all based on educational research. We're going to uncover 4 hidden traps in how math is often taught that can really set students up to fail. Now, this isn't about blaming teachers, it's about trying to understand the system itself.
Okay, so here's our roadmap. First, we're going to bust that math gene myth wide open. Then, we'll get into the 4 big traps: the additive cage, the multiplication lie, toxic math words, and this really surprising one, the help paradox. And by the end, you'll see exactly why your struggles with math probably weren't your fault at all.
All right, first up, the math gene myth. You know, the idea that you're just born bad at math is kind of an easy out, but the research shows it's just not true. It stops us from digging deeper and finding the real reasons for all that math anxiety. So let's look at the first one of those real reasons.
So this brings us right to our first big trap, what researchers call the additive cage. Think about it. Our very first experiences with math are almost always about adding and subtracting things. And that seems totally harmless, but this is exactly where the foundation for a kind of mental prison gets laid.
To really get this, we need to understand a key concept from education research called a didactic obstacle. It sounds fancy, but it's simple. It's a way of thinking that's super helpful at the beginning, but later on, it actually becomes the reason we make mistakes. It's like knowledge that eventually turns into a roadblock.
So here's how we end up in that cage. We start out by counting physical things, right? Then we solve simple little problems about parts and wholes. Our brain gets so good at this and so used to it that it just defaults to seeing all math through the lens of adding or taking away. This becomes our go-to setting, and that's how we get trapped in what they call the additive cage.
Being stuck in that additive cage makes the next big step, multiplication, really, really tricky. And that leads us to our second trap, the multiplication lie, which is all about how a simple, easy explanation can completely fall apart on us later.
Okay, this slide shows you the exact moment the whole thing breaks. We're all told that 3 times 4 is just a shortcut for adding 4 3 times. And yeah, that's intuitive, it fits right into our additive cage. But what about 0.7 times 4? How in the world do you add 4 to itself 0.7 times? You can't. The model completely shatters.
And this is such a critical moment. Like the quote here says, when students have to ditch their understanding and just start memorizing rules that don't make sense, that's the beginning of the end. That's the exact point where the joy of figuring something out gets replaced by the anxiety of just trying to remember a bunch of random procedures.
Now, making this problem even worse is our third trap, toxic words. It turns out the very language we use in math problems can trigger the wrong reflex in our brains, sending us down a totally wrong path before we even know what's happening. How many times more? It's a multiplication question, but for a brain that's already stuck in that additive cage, the word more just jumps off the page. It primes our brain to think about addition, creating this mental tug-of-war. We hear more, and our brain thinks plus, even when the problem needs us to multiply. It's a total linguistic trap.
Okay, this leads us to our final and honestly, maybe the most stunning clue in this whole investigation. Trap number 4 is the help paradox, and it turns out that the very techniques we use to help struggling students can sometimes be the very thing that traps them even further.
Yeah, it's a real paradox when help actually hurts. Well-intentioned support can totally backfire and make the problem it's trying to solve even deeper. So how is that even possible? Let's break it down.
This cycle explains it perfectly. So a student is struggling with abstract math. The go-to solution? Bring out concrete objects, like little blocks or tokens. But what do we do with blocks? We count them and we add them. So this unintentionally just reinforces the exact additive thinking that's causing the problem in the first place. The help that was supposed to build a bridge ends up just digging the hole deeper.
So there we have it. We've uncovered 4 major traps: the additive cage, the multiplication lie, toxic words, and the help paradox. Now it's time to put all that evidence together for our final verdict. it really wasn't your fault.
And here is the single most important takeaway. If you've struggled with math, it is probably not because you have a non-math brain. It is far more likely that you just got caught in one of these traps created by the very system that was supposed to be teaching you. The responsibility so often lies with the institution, not with the student. The failure isn't personal, it's systemic.
And all of this leaves us with one huge final question to think about. If the teaching method itself is the problem, then how do we start to rebuild it? It completely shifts the conversation away from what's wrong with the student and toward what's wrong with the way we teach. And that is a really powerful thought to end on.